I see somebody's on. If you're on and you can type, let me know who you are. Oh, got 3 on. Okay. Hey, JR. If you guys want any of the questions you want me to go over, just I would like to do the review, or we can go ahead. Hey, Jayla. Hey, Dan. Hey, Kayla. If you guys have any questions, or if you guys want, we can go through the review. I think there's still a delay. It's not as bad. It's definitely not as bad. Yeah, it's a lot better now. So those of you that are on, if you want to ask or of anything on the review, or if you just want to kind of go through all of that, that's fine. Just put it in the comment box and we'll go from there. Anybody got a choice? Okay, I put a little comment in there for you guys. Just make sure you can hear me. Anybody on? There we go. It is a cute little triangle, but yeah, you're right, it is. Your cuteness is wrong. Okay, struggling with number 2. Okay, so let's go ahead and we'll look at that one. Thank you, Kayla, for stepping up there. So let's check it out. Let me get it straight in there for you. There we go. Yeah, so this one requires a little bit of extra work. So, Kayla, where did you start off on that? Did you get anything done on that? Okay, plotted the points. That's good. So that's definitely the first thing you want to do. So I'm going to plot those on there real quick. If you guys are just now joining on, I'm just going to plot these points in here. So A is -5, 1, 2, 3, 4, 5. What is it? -5, 4. And then I've already done this problem, so I know they kind of line up and make a triangle or a rectangle. Okay, so if you plotted the points, we'll go ahead and connect them. Okay, my picture's not perfect, but that's okay. Oh, okay. I'll raise it up a little bit. There you go. It should be better. So we've got that. It says, what type of polygon do the points form? So does anybody know on here? Yeah, it made a rectangle. Okay, Kayla's got that. So the reason why we know it's a rectangle is 2 reasons. We know that these links are the same. If you count them, let's just go ahead and count them. 1, 2, 3, 4, 5. Let's put that on this side. If that's 5, and we count that, that's also 5. And if you count them across, that makes 10 and 10. So right now we know that all the sides are the same. I'm just reading the comments here. If we know that these sides are the same and these sides are the same, but in order to know it's a rectangle, technically you have to know that this makes a right angle all the way around. And we do know that this makes a right angle because we have horizontal and vertical lines. So that's a kind of easy one. We're going to get into some ones that are a little bit more difficult than that. So, does somebody, can you pop on there in your comments? It says your friend claims that the area has an area of 1250 and a perimeter of 150. So somebody want to tell me what they would do in the comments there to find the area and the perimeter? See if this highlighter works. It's not the best. Okay. Area or perimeter. You can even type in your comments what the perimeter should be pretty easy. Got perimeter, got area. Good job. Yep. So you're right, Jayla. To find the area, we just do length times width, which should be 10 times 5. Whoops, I went ahead and did the math. Let me erase that. 10 times 5, which is 50. So this problem's a little tricky. And then to find the perimeter, all we're going to do is just add up all the sides. So remember, perimeter is just like you're walking the perimeter of a of like the playground. You're walking around the outside. So it's 5 plus 10 plus 5 plus 10, which makes 20, 30. So when I first read this problem, I'm like, wait a minute. This isn't even close, to what your friend was saying. Not even close. But there actually is an answer to that. Okay. Looking there. Yes. So your friend's not necessarily wrong right now. They technically could be right, because right now we're saying that each square is equal to 1 meter. Okay. But what if we said each square was worth 2 meters, or 3 meters, or 4 or 5? Okay. So I want you guys to think about that real quick. See if you can multiply each one of those by the same number and get an answer of what your friend was asking. Anybody get that? The bottom one's kind of easy. So, the perimeter should be pretty easy to do. What could we multiply the perimeter by to get this perimeter if each unit was worth not 1 meter? What could we multiply that by? Anybody? Okay. I'm getting crickets here. Oh, yeah, Kayla, 5, yes. So let's look at this. If we said each unit, each square was worth 5 meters, so each one of these was 5, I'd multiply this by 5, and that would give me a perimeter of 150 meters. Oh, yep, everybody, that's good. You guys are all on that. Excellent. But here's the problem. If If we said each one of them were worth 5, that would give me 150. But if I do this one times 5, whoops, if I do this one by 5, it's going to give me 250. So that's no good. But somebody, what could we multiply the bottom by to get 1250? The easiest way would be is just divide those out. So take 50 divided by 1250. Okay. I'm getting here. So what I would do is 1250 divided by 50, or yeah, 1250. So if my friend says it's 1250 and I already have 250, if I divide that out, what do I get? Anybody get it? Yep, looks good, 25. So if each square was worth 25, oh, no. I'm thinking this out in my head here. Can't do it that way. Can't do it that way. Because here's the thing. Hold on just a second. Yeah. So the area is a little funky because think about it. We can't just multiply the area by 5. We've got to multiply this by 5 and this by 5. So it would be I have to multiply this by 5 and multiply this by 5. And if I do that, check it out. If I do this by 5 and I do this by 5, it gives me 1250 meters. So here's the thing. If your friend said each square was worth 5 meters, then they're actually right. Now, this is a really good problem. You're not going to see anything like that on your quiz where you have to multiply anything at all by that. So that's not, I wouldn't be too stressed about that. If you guys can do this, and if you can say that that's a rectangle, that's perfect. So that's how you do it. Okay. How about any other questions? Kayla asked about number 2. I don't mind. We can do any problem you want on here. The number 3, just as we're kind of looking through it, it has tons of answers. You will see a question like number 4 on your test. There we go, number 4. Okay. So let's flip over to number 4. So that's on the next page. We need to get there. All right, let me get this looking nice for you guys so you can see it pretty good. Oh, need to move my camera up a little bit. There we go. Okay. Thanks everybody for coming on here. I can stay on here as much as you want. So number 4, when we look at that, what's the biggest issue when I look at this equation right here? There's something really major that's going on that's not so good when you look at that. I've got this right here. What's the biggest issue? And you will see stuff like this on your test. Yeah, that's fine. We've only done question number 2, but you definitely probably want to go back and check that out. Yeah, Kayla, you're right. No slope. Currently, there's no slope. So what do I need to do to this problem to get it so that I can figure out the slope? Because I can't do either one of these until I get the slope. Anybody got an idea? Put it in the comments here. Yeah, Haley, we can do number 10 as soon as we get through. Yeah, definitely we'll check that one out. We can do that one next. No problem. We're currently on number 4 if you just got on. Okay, I'm getting crickets here. Even if you guys are watching and you like don't know. Ah, yes, good job, Bella. So we need to set this equal to y so we can figure all that out. So the very first thing we need to do, let's write this down. X plus 3y equals 12. Okay. I need to get y by itself. So I'm gonna move this x. I'm gonna do the opposite. Whatever I do to one side, I do the other. Gives me 3y equals 12 minus x. And then I have to divide both sides by 3. And just a good little friendly reminder, if you're not too awesome on this, is you want to divide everything by 3. That's where a lot of students get tricked up. So 12 divided by 3 is 4. Oh, that's a tricky part right there. Negative x divided by 3. Does anybody want to put in the comments there what that should be? I'll give you a hint just on the sign. A negative divided by a positive is a negative, so we know we're going to have subtract. Yeah, good job. Negative 1/3. All right, so now we're ready to do this problem, and you're gonna have to do this on your test. You're gonna be given something like this. You're gonna have to manipulate it around and get it to y equals form. Okay, now let's read the question. Write the equation of the slope-intercept form that passes through the point that and is parallel to the line given. So how about in your comments there, somebody put what we're gonna put in for our put our slope. So put m equals in there. Hey, Ethan. Put your slope and then put the point in the comment, what we're going to plug in. And here's our equation. Y minus y sub 1 equals m times x minus x sub 1. I need a parallel line, and I need the ordered pairs. All right. Come on, peeps. If it's a parallel slope, what slope do I need? Just going to write it down here. Awesome. Yes, check out the comments there by Jayla. That's exactly what we're going to pop in there. So, y minus... I noticed in class today a lot of students were still struggling with this. So if you need to write this in here, x sub 1, y sub 1, that's perfectly fine. So x minus, or y minus y sub 1 is 1 equals my slope, which is negative 1/3. And again, just remember, we're subtracting a minus, so that's a plus 3. Distribute negative 1. And a plus 1. Okay. So some of those, yeah, perfect, Domsy. Way to get that in there. Yeah, parallel slope is the same slope. Sorry, I was doing the work, not checking out the comments. Yeah, those are all great. So this line is parallel to this line because their slopes are the same. But this new one that we created, if you were to graph it on paper, would go through that point. This line would go through that point. So let's check out the next one. We have same question, but they want it to go through a new point, and they want to be perpendicular. And I know this is going to be an issue on the test, is that you guys are pretty good at these, but you might not read it and do all the questions as parallel, or you may do them all as perpendicular. So I like how Domsy put in there, kind of, if you guys look in the comments, the slope intercept. Let's figure out first, if you guys want in the comment, put what our perpendicular slope would be. So our slope, I'll write it real big, and this problem was negative 1/3. But I don't want a parallel line. I want a perpendicular line. So what slope are we going to use in this next problem? Yep, 3/1 or 3. Either one's good. 3/1's good if you're going to graph it, so you know how much to go up and over or down and over. But since we're just going to use that equation, we're going to use 3. So y minus y sub 1 equals m times x minus x sub 1. Again, it's not a bad idea to go up here, put your x sub 1, y sub 1. So I'll quietly work this, and you guys can check it out. I know it gets kind of blurry and zooms in and out. Sorry about that. So you guys can check that out, see if that's what you got. Just give me some sort of feedback on there. If you got it, say yes. If you didn't get it, say no. Or you don't have to comment at all. That's fine. As I'm waiting on this reaction time for you to put your comments, we will be going to question 10, and I definitely want to go back to number 5. So those of you who don't know how long you're going to stay on or not, I at least want to do number 10 and go back and do that proof for number 5, because you do have one proof. Excellent. Getting a lot of yeses on there. We do have one proof on your test, and it's very similar to question number 5. So let's go ahead and flip to number 10. You're definitely not going to see anything as difficult on this on your test, but this is going to show up again. Let me get this going for you here. Here we go. Oh, let me come out a little bit. There we go. Alrighty. So we're on number 10. Now, what I'm going to do... Oh, I'm seeing here. That is all you have to do for B. Yep, they just wanted the equation of the line. So if we had to graph, do we have to? You don't have to graph anything on this test because it's all on the computer and it's all multiple choice. So you should be good for that. I do want to kind of, well, we can go over it in class. I'll wait and save that for everybody. But let's go ahead. We'll go on this. Letter A. It says name a pair of skew lines. Now remember, skew lines are lines that never intersect, but they're not parallel. Okay. Anybody want to take a wild guess? Another thing is too, skew lines are also not coplanar, or they are non-coplanar. Okay, A and E I see. Let me look here. Yes, A and E definitely works. Yes, they have to be on different planes. D and G. Yes, D and G are on opposite planes, okay, and they're not going to intersect. So those would work. In my answer key, they have D and F, so that's what I'm going to put. Well, they're lower cases. I better leave it that way. If I make them uppercase, that means they're a point. D and F. Okay. That's fine. How about, so I think that one's pretty basic. Basically, just don't pick things that are parallel on like the brick wall there. That's basically the best way. A pair perpendiculars. It's really hard to see in that picture, but if you look at 6, there is a box around that, or a right angle. So can somebody give me, there's one really good answer for parallel, or for perpendicular, I mean. E and F, we don't know if those are perpendicular because there's no sign over there. So I can't use E and F. There's really only one set that you can definitely say are perpendicular. Yes, yes, awesome guys. D and B. Because if you see right here, it connects D and B. So those are the only ones. And the way you just want to write it is D is perpendicular to B. Or you could write it the other way. Well, not B is perpendicular to B. Okay. Yes, that works. Oh, now I'm all fuzzy here. Let me see if I can get that. There we go. Okay, how about parallel? Oh, this one's tricky. Parallel lines. Which ones are parallel? So remember, they have parallel. They're not going to intersect, and they're on the same plane. Okay, I see A and B. A and B are not. They are not parallel. So as you're sitting there and you're trying to answer this, think in your brain, the only ones I could prove that were perpendicular were D and B because they were marked. Is there anything in the picture saying that any of the, or that they're giving you that the lines are parallel, or do you see any kind of marks on any of these saying they're parallel? So I'm going to draw in here for you. If they had little arrows like this, we could assume that those are parallel, but there are no marks on any of the lines. So our answer to that is none. There's no markings. That's actually the best answer. None. No markings. Okay. Good job, Bella. Okay, last one. Corresponding angles. Here's the thing you have to remember, and this is gets kind of tricky. Corresponding angles are angles that are just in the same location. If I say the lines are parallel, then those corresponding angles are congruent. So there's also all kinds in this picture. There's all kinds of alternate interior, alternate exterior in this picture, but they're not congruent. They're only congruent if they're parallel lines. So there are lots and lots and lots of corresponding angles. How about this? If I pose this to you guys, give me a corresponding angle to angle 3. Put that in the comments section there. Let's do one that's for angle 3. Yep, 7 works for sure. Technically, there's one more that would fit with angle 3. Yep, good. 3 and 7. There's one more. Yep. Let me use my highlighter here for you. I'm so fancy. 3. It's in the bottom left. 7's in the bottom left. 11's in the bottom left. Yep, very good. Very good. So I do want you to kind of put that in your minds, though, is that they are corresponding, but they're in this problem, they're not congruent because they're not parallel. So if I said the angle 3 was, let's say, 100 degrees, that doesn't necessarily mean that either one of these will be 100. If they were parallel, then all of them are 100. Okay. We are going to move on backwards to question number 5. I want you to at least be able to do that one. I'll get to that. Okay, so the way this one's written is it has the stuff over here and the picture over here, but our proof's down here. This one's kind of basic, but the nice thing about these problems are the proofs are pretty fast and they're not super huge. So here we go. We got M is parallel to N. That was given. 1 is congruent to 2. That's given. Now what I would do is I would make sure I'm doing the stuff in the picture. Man, is it blurry? It's not blurry on mine, but it looks like the stream's kind of blurry. Sorry if it is. There's nothing I can do about that right now. Let me try something real quick. Okay. All right. So what I would do is I would go into the picture and I would mark that. They've told me that angle 1 and angle 2 are congruent. So I would go up here and I'd say, okay, I've already proven this. It's been given to me. And then they say 1 is congruent to 4. Okay. 1 is congruent to 4. So if 1's congruent to 4, how many arc marks would I put with angle 4? Put that there in the comments section for me. How many arc marks would I put with angle 4? Okay, I'm getting some different answers there. We are saying 1 is congruent to 4. Oh, it's split almost 50-50 here. 1 already has 1 arc mark. So if this has 1 arc mark, this one's just going to get 1. And then what are we going to put for our reason in there? So we're just looking at angles 1 and 4. What are we going to put for our reason? Yep, vertical angles. They're right across from each other. Look at the picture right here. They're right across from each other, so those are vertical angles. And then the next step says 2 is congruent to 3. So in our picture, we already have 1 arc mark for this, and they're saying these two are congruent. So that's going to get 1 arc mark. And what can we say for our reason? So I know a lot of you just popped in vertical. What's our reason for number 4? Yep, vertical again. Yeah, look at the picture. They're right across from each other. So here it says 2 and 3. I look at the picture. They're across from each other. That's vertical. Okay. Now the next one is blank. But here's what you need to say. You need to say, okay, it says substitution. When I see substitution, normally just one thing changes. Okay? Only one thing changes. So I'm only going to change one of these two things up here for substitution. I'm going to substitute something in for angle 2 or something in for angle 3. Now when I look back up here, I don't see anything that works. For angle 3. Let's see here. Can't you substitute 2 into 4? I can't substitute 2 into 4. Okay, this one's a little tricky. Yeah, so Bella, we are getting to transitive. Yes, whoever said so. Angle 4 is congruent to angle 3. Yes. So if I look right here, I'm going to keep this one the same. And I'm going to say that 2, if I look at my picture, 2 and 4 are congruent. Okay. So all I did was, I don't like that that says substitution though. This, technically, I think this one should say corresponding 2 and 4. But let's go ahead and look at the next step because let's see here. J-lat angle 2 is congruent to angle 4. Yes, perfect. Sorry, this is getting funky for me. Yeah, you guys are good. So let's just check this out. Now that I've got this set up, and I just want you to kind of keep this in mind when you're taking your test, you're going to get to the point where you want to set up transitive property, basically. So if you guys look right here, I'll draw it out like I do in class. I have angle 2 is congruent to angle 3. And here I have angle 2 is congruent to angle 4. So then remember, if I cover this up, then those are going to be equal to each other. And that's where we get 3 is congruent to 4. And that's transitive. Okay. Alrighty. Okay. I know some of you guys have been on here for a while. I'm willing to stick around for 1 or 2 more problems if you want. Or if you want to get off here, that's fine. There is one more proof, which is number 11. There's also the ones I asked you to do for tonight. Those of you that are in my 4th bell, I wanted you to do 7 through 11. My 7th bell, I didn't get to assign you any problems. Does anybody else want to see any? Our questions 7 through 9 on the test. There definitely are some that could be a version of 7 through 9 on the test. And Bella says number 11. So let's do this. Let's do number 11. I'll do number 11 with you because that's another proof. And it's very similar. Actually, I think it's the most similar to the one that's going to be on the quiz or test. I keep saying quiz. On the test. And then we can go back and Kayla, if you want to ask like 7, 8, or 9, any of those, look at those while we're kind of doing that proof, and I'll do one of them, maybe 8. That might be a good one to do. So let's do that. I'll do 8 and 11 with you guys, and then maybe we'll get off here. Okay, so let me go. Now just remember too, when you take your test online, we will have everything. Come on. There we go. We will have everything for you to kind of drop in there to plug in. Because it'll be like a drag and drop. All right, so we're going to write us a proof. So we're going to put our statements and our reasons. Okay. All right, lay it on there, lay it on there. Can you tell me, can you tell me how to get to Sesame Street? No, can you tell me what my given is? Yep, L is parallel to M, so we're going to put that first. L is parallel to M, and that's a given. Okay, a nice thing you might want to do is you might want to just put those arrows in there so you know. It's always good to label your picture. And then there's a second given, so we'll go ahead and put that one in there. What's our second given? This is like a 5-step proof, and we've already got 2 of them. Uh-oh. It looks like my stream is kind of locking up. I don't know if it is or not. Okay. I'm just going to try to work through this just in case we get all... Yeah, angle 1 is congruent to angle 7. Good. So angle 1 is congruent to angle 7. So again, I would mark that. I would put that on there. I would say 1 is congruent to 7. Now on your test, you're not going to... I would write this down on my paper. I would draw the picture and I'd mark this stuff as I go along. So I got 1 is congruent to 7. That's a good starting point. We're trying to get to prove from here to here. But remember, these are not on the same line. Or I'm trying to prove that these lines are parallel. So what I have to try to do is prove that something here is parallel with something, or congruent to something here. So that's what I got to try to do. I need to get some sort of information here and get it to here. So let's think about it logically. What is going to be the best way to get from here, from this angle to something here down to here? What angle do you think we should say is congruent to 1? Oh, you could go that route. You could go 5. Yeah, you could definitely go 5. I'm going to go to 3. I'm going to work this way. You could do the same, but I'm going to go from 1 to 3. I know... Oh, sorry, you can't go... Sorry, I just looked at my picture. You can't go from 1 to 5 because you don't know that these lines are parallel yet. You have to go from the parallel line to the parallel line. So I have to go from 1 to 3. Kayla, Bella, does that make sense? These lines I don't know if they're parallel yet, so I can't prove they're congruent. These lines I know are parallel, so I can prove they're congruent. So what I'm going to say is I'm going to say that angle 1 is congruent to angle 3. Remember how earlier I said in the stream that if the lines are parallel, you can prove they're congruent. So I know 1 is congruent to 3, and that's corresponding angles. And then, so I'm going to put my arc mark here. So if 1 is congruent to 3, and I know 3 is congruent to 7, okay? So in this one, I can now say, if I know 1's congruent to 3, then I know 3 is congruent to 7. There's 2 acceptable answers. Yeah, I think the picture does help. There'll be a picture on the test, I'm pretty sure, but I would actually write the paper on my own paper so I can mark on it. So there's 2 answers for this reason. One's probably pretty easy for the reason. The other one may not be so much. I would take either answer. Does anybody got a guess? Let me show you my dog. Oh, it's upside down. Hold on a second. Tank. You say hi, Tank. There's Tank. That's my dog. Hi, buddy. All right, sorry. Got distracted. Okay. Yes. Good answers. Corresponding and transitive. Yes, both of those work. Because if 1 is equal to 7 and 1 is equal to 3, then 3 is equal to 7. So I would personally put transitive. It just makes you sound smarter. And that is going to be more of an answer you're looking for. So now I know 3 is congruent to 7. So I have now proved that these are congruent. If I have proved that these are congruent, these 2 angles are congruent, then I now know that A is parallel to B. Okay. I know that A is parallel to B because of, and this is kind of important to understand. If corresponding angles are congruent, then the lines are parallel. Okay, so there's 2 ways to say it. If these lines are parallel, then their angles are congruent. But if I say, if the angles are congruent, then the lines are parallel, the actual answer to this is the corresponding angle converse. Okay, and the reason why it's the converse is because I know that these angles are equal, so now I know those lines are parallel. If I say the lines are parallel, then I know the angles are congruent, then that's corresponding angles. That's kind of the way to look at that. All right. I know some of you guys are dropping out on me. It's fine. I'm going to do one more because we've been on here for a while. Hopefully this has helped you out. Let's go back up to number 8. Tank's leaving the room. See you, Tank. Get this so it's not blurry. There we go. Okay. So I've got x's and y's in this problem. So it's going to be maybe a little bit difficult, but there's a huge key in this one. It says I've got parallel lines. So if I know I got parallel lines, I can mark some stuff that are congruent. In the comment section, can you tell me what's congruent? What could I put in one arc mark with another arc mark? Let's see here. Yes, Jayla's right. Because if these lines are parallel, then I know these angles are congruent. So I can set those equal to each other. So I can say y minus 4 equals 45. Add my 4. Y equals 49. Okay. I mean, if you think about it, if I plug it back in, 49 minus 4 is 45. So that works. No, that's okay, Bella. All right. But here's the tricky one. Now what am I going to do with the x? What can I do with the x? Not getting much of an answer here. So what I can do with the x is if I look at these, they're a linear pair. They're side by side. So if I cover stuff up, if I cover that up, what does that make? Oh, Jayla, you can definitely do it that way. That's fine. Can definitely do it that way. But probably the easier way, yep, it's a line. So the easiest way I would say, and you can do it the same way, you're going to get the same answer. But I would just say 3x plus 45 equals 180. This plus this is going to make a straight line. Yep, supplementary, good, linear pair, 180. Those are all fantastic. So if I minus 45, Jayla, check this out. If I minus 45, I get 3x equals 135. That's exactly where you were. If I divide that by 3, x equals 45. Okay. Okay, so here's what I'm going to do real quick. Since you guys are on here and we're like an hour in, I don't want to destroy the time. I'm going to just go ahead and give you the answers. I'll write them down for you. And you guys can copy them, and then at least you'll have the answers. So, number 7 If you do the work right, you get x equals 21. Number 9, if you do the work right, you get x equals 25 and y equals 113. I just want to see if there's any others that we haven't done. Those are all the ones that you probably will need the most help with. Real quick, if you want, if you're still watching, we'll just flip to number 1. I'll just kind of give you a quick heads up how to do that one. This is really it's probably buffering for you guys. Just real quick, remember to find the area and perimeter. All you do is count these squares right here. 1, 2, 3, 4. Count these. 1, 2, 3, 4, 5, 6, 7. So to find the area, it's 1/2 base times height. So base and height are already given to you. Half of 4 is 14. Okay. And then just so you know, I'm not going to do it, but to find the perimeter, you're going to have to do that on your test, I'm pretty sure. EF, what I would do is I'd write the length of each one of them. EF is 4. ED is 7. But DF, okay, what am I going to have to do to get DF? I have to do distance formula to get this. So that's 2, -4. Yep. So you have to do the distance formula for those. If you do the distance formula correctly, you should get approximately, if you do it right, I would do this, it's good practice, but you should get about 18.06. So the perimeter would just be these added together, which is about 1906 units. Okay, so we're at it like at an hour and 5 minutes, so I'm just gonna call it quits for a night. I appreciate you guys that have stuck around for the whole time. Hopefully it was helpful for you. Those of you who kicked on late, this should be uploaded pretty soon. You can go back and watch the other ones. So thank you so much. Have a wonderful evening, and we'll see you tomorrow.